My name is Adam Crabtree. I work at LinkedIn as a mobile server engineer. I'm also the mobile server Node.js training lead. I do all the Node.js training at LinkedIn. We do a week-long boot camp every month. I train about 15 to 30 engineers a month. The mobile server team itself, though, is actually not that large, as that the training would suggest. It's only about, the constant flow is that we typically have about 15 full-time developers at any given time. I also am the founder and organizer of Baynode and also the founder of Dallas.js and Dallas.node, so that's fun. While we're waiting, I guess, I'm just going to be talking about the difference between control flow and asynchrony. It's something that is not a common vocabulary that's in most people's vernacular. When people talk about, promises versus callbacks, you find a lot of apples to oranges comparisons. And so a lot of what I'm going to be talking about is kind of a primer so that when you do hear people talking about control flow or callbacks versus promises, that you kind of have the proper terminology to be using and understand what their relationship is to one another. So, I guess we could keep waiting. Yeah. Well, I'm worried that that's gonna, because last time it did come on.
Oh, did it?
So, give it a few more seconds, and then we'll try it again. Oh, no source found. That's a good call. Oh, this is not connected, and that's probably why it took a long time before.
Okay.
It's starting to show up.
Is it? Okay, thanks. Okay, so my talk, a little cheeky, is a tale of two asynchrony. So when I use the word asynchrony, it's not a common word that a lot of people use. It's really mostly mentioned if you're a control flow library developer. But when we talk about asynchrony, we're talking about an object or function that represent an asynchronous value or error. So I'm going to break this down into two halves. The first half I'm going to talk about is any object or function. So essentially the representation portion of the asynchrony. When we talk about asynchrony, here's the examples that you're probably most familiar with. It's within the Node community, it's typically either callbacks or promises. Callbacks are a form of asynchrony. They're going to give you either an error or a value back in return, and then you could then choose to deal with that error or deal with that value depending upon what you have. Promises is a similar situation. You're either going to get one value back or you're going to get an error back. In neither of these cases, you're going to get both an error and a value. In all asynchrony cases, you're almost always going to get, well, I can't think of any, I'm sure maybe there are some, but you should always get at least an error, and if not an error, then you're going to get a value, but you'll never get both. So that's what I'm going to be talking about. So when I talk about asynchrony, it's important to understand that they're not just, that they have contracts. They have a formal explanation of how they're supposed to behave. With promises, we have an actual spec, which is good. But before the actual spec existed, there was also a lot of implicit contract within promises as well. And so the promise spec actually developed slowly out of the various implicit expectations of the promise libraries that had been built. With airbacks, or Node.js style callbacks, when we talk about airbacks, we're going to hop back. When we talk about airbacks, we're talking about callbacks specifically that follow the Node.js pattern of error and value. Not all callbacks have an error as the first argument, so when we use the word errorback, I will be using that interchangeably with callbacks throughout this presentation, but we're specifically talking about Node.js style callbacks with error argument being passed as the first value and only a value being passed as the second argument. So that function is going to have an arity of 2 or a length of 2. It will never have it, or usually will never have more than one argument. Sometimes people will abuse the contract. That's not as important. That's probably, it tends to be one of the least important aspects of the contract if you were to pass more than one argument, but it's still an important aspect. I'm going to cover these to some degree in a next slide. But also, I just want to mention, ideally, your asynchrony, will get, whatever it is going to have tests to support it. So most of these don't. So there's no, to my knowledge, there's actually no callback contract formalized anywhere within the Node community. And if anybody does know where that is, by all means, raise your hand and tell me. I was a little surprised when I started doing Node.js training, and I was putting together the expectations for callbacks, and I thought surely this is defined somewhere, and actually it was not. So I actually put one together. But to jump right into the callback or errorback contracts, you don't always think about it, but all of these are actually formal expectations or informal, implicit expectations of the callback contract. And so what those are is essentially that it's going to take 2 arguments and only 2 arguments. The first argument is going to be an error. The second argument is going to be the result. You'll never pass both, so you'll never get both an error and a result. You'll always get one or the other. And ideally, an error should be an instance of error. So it should not just be like a string or false or null. What it especially should not be something that's falsy if you intend for it to be an error, but it should also ideally be a real error. So that you can get a stack trace because you need to figure out where that error originated from. Additionally, it must never execute on the same ticket the event loop. So what we're talking about here is if I call fs.readFile, and let's say there was some caching supported by readFile, and so it had the value already, and it didn't have to be an asynchronous call, it should still be asynchronous. You'll find sometimes that this is another aspect of the callback contract that people violate very regularly because it requires additional effort to make sure that you call process.nextTick instead of just immediately calling the callback. But it's important because what you're trying to create is predictability. You're trying to create predictable code paths through your code that when people make calls to your asynchronous functions, that they're not going to get one code path versus another depending upon the internal state of that callback. So that's why it's still best and appropriate that you actually still call it on the next event loop tick. It's also appropriate because in Node, you'll find with stuff like streams, we will create a stream first, and then we'll add a bunch of event listeners onto it, and then we might do something else like call .listen. And so it's important that sometimes if you do return a value, you give whomever it is that's dealing with that value an opportunity to actually attach listeners onto it and basically do something with it. Because if you call your callback immediately, and you theoretically also return a value for your function, there's no way for the code that invoked your function to actually do anything with that return value because your callback's going to be called before your function's returned. So, yeah.
Can I ask you something? What do you mean by for return value is ignored?
So the return value of the callback should always be ignored. So not the return value of the function, but if for some reason the callback returns something, like let's say it returned an error or something weird, it should be ignored. Okay. And this is mostly to basically ensure that there's no weird, there's no gotchas, essentially, right? That you're not saying, oh, for me, I treat callbacks that return a truthy value as some special meaning. And so that's kind of part of this. Must be passed as the last argument to the function. This is something that is kind of, you'll see, that's probably the one that's never violated. The only time that that's violated, it actually isn't really even an example, but I was going to say set timeout because that API comes from the browser, but it's actually not really an error back, so it's not really even an example of when it's violated. But nonetheless, with something like set timeout or set interval, the callback is not the last argument. But that's actually probably the one that's almost never violated. Return value is ignored, and we were just talking about this, but I don't have a slide for that. But essentially, if your callback returns a value, the function that invoked your callback, it should have no impact on it whatsoever. So if I'm a function and I'm past a callback and I want to do something and I then call that callback, if that callback returns a value, I'm going to completely ignore it. I'm going to hop over some code real quick just so I can illustrate that a little bit better. So ignore the slide, look at the code. This callback right here, if it were to return a value, that should have no bearing on the context of this function execution. And that's essentially what I'm talking about here. So if it returned null, if it returned true, if it returned an object, if it returned anything at all, we should be ignoring that. It must not throw and it must pass resulting error. So this is important because of asynchronous execution. You can't, try catch is a synchronous concept. You can't catch asynchronous errors within JavaScript because it's actually not going to be caught by wrapping it in try catch. So if I call fs.readFile, I wrap it in a try catch, but some callback down the line throws an error, I have no way to actually catch that error. So it's important that you make sure that you pass the error down the line through the callback so that I can get that error up through the callback and then I can deal with it. So to hop back over to my example. Essentially what we're talking about here, actually I'll just hop right here. This is exactly what I'm talking about. So when we talk about making sure that we pass along the error, if we were to throw right here, this is not the same tick as right here, and so any code that actually invokes this function and wraps it in a try catch will not be able to catch this error. So it's important for the sake of the callback contract that they're able to actually deal with that error. And so the way that we allow them to deal with that error is by not throwing, but always ensuring that we pass the error back to the callback. So I'm going to hop right back real quick. And I'm going to come back to all those slides just so I'll spend a little more time on them. And so it must never be called more than once. So if you call fs.readFile and it calls your callback 5 times, that would be a little strange. You're basically saying, I want this function to do one thing and one thing only, and I want one value returned only, and that callback should be returned and called only once. So I'm spending a lot of time talking about the airbag contracts. That's for 2 reasons. One, it's the default built-in asynchrony in Node.js. There's no built-in promises for Node.js. There's no built-in async generator support in Node.js. There's no built-in thunk support. These are all different types of asynchrony in Node.js. Well, there sort of is, but not really. But callbacks are the default asynchrony type in Node.js. And so it's important to understand when you're using callbacks, 2 things. What you can expect out of any function that you pass your callback to, and what you yourself should be enforcing for anybody that calls your code and gives you a callback. And these are the expectations. I'm going to talk a little bit about if this feels cumbersome. It feels like a pain in the ass that you would have to enforce this constantly. I'm going to talk about that. That's essentially where control flow comes in, or control flow can come in. So I just talked about the callback contract, which was implicit. This is the promise spec. It's a spec, so it's obviously a lot longer. But it fits on one slide, right? So
Probably want to minimize it.
But it's a spec. It's done. It's formalized. If you want to depend upon promises, just the same way that if you want to depend upon callbacks, you can do that. It's very clear if you actually read through the spec. One common recommendation at LinkedIn that one of our staff engineers makes to new mobile server developers is, if you're new to Node, it would be really great if you just go look at the A+ spec and implement your own promise library, because it really gives you an idea of like how asynchronous programming works and kind of the expectations, and gives you lets you get your hands wet, dirty with JavaScript. So I was just talking about the asynchrony objects or functions, the representations. Now I'm actually going to talk about the values or the errors, essentially what is returned by an asynchrony. There are 2 primary results to any operation, a value or an error. This was part of the callback contract, but it's actually also part of the promise contract or the promise spec. So pretty much everything that I mentioned in the callback contract is actually also has a corollary in the promise spec, because a lot of these values are characteristics not of the actual specific asynchrony, but actually characteristics of general asynchrony itself. Stuff like your callback should always be called on the next tick. You should always only ever get a value or an error. Your errors should be, actual instances of errors. All those things actually are also explicitly, well, except for like the error one, but in my opinion it should be. But no, I think it might be in the spec. But regardless, they should all essentially be characteristics of all asynchrony, that they should enforce all these same similar characteristics. So asynchrony must deal with both. In both here I'm talking about errors and values. Sometimes we have to deal with the values versus the errors manually, like with callbacks. Sometimes we get to deal with have errors dealt with automatically, like with promises, and values will also be dealt with automatically with promises if we choose to call .fail to capture the error. The value will bubble up until somebody intercepts it. So sometimes your results are handled automatically, and sometimes your results are handled manually. I was talking about this earlier, but this is essentially how in a callback construct we have to deal with the errors ourselves manually. This is a bad way to deal with the errors, because if we throw it, that callback, you're violating the callback contract, because that callback expects to be passed an error if there is one. And so if you throw, you won't actually allow for whomever calls you to deal with the error. So what we need instead to do is to pass that error. Again, and I was mentioning this earlier, but we just want to make sure that instead of throwing, we pass it down the line so that the callback can handle it. For promises, though, you'll see that the error handling is automatically handled. So it makes it a little bit nicer, because what promises do that callbacks don't is they actually encapsulate their spec and their contract within the actual API. So whereas callbacks are incredibly simple and incredibly low level, because they're pretty much just a function with a length of 2, instead, promise is a spec. It's a whole encapsulation of an object of an API. And because of that, it allows for some nice things like automatic error handling, automatic value handling, so that you don't have to manually pass them down the line. So you'll find, what I mean by that also for manual value handling, here this is an example of what I mean by manual value, or automatic value handling, because this string function is going to return a value, and whatever the return value is will automatically become the new value for this promise. So if you're not familiar with the promises, you're covering promises fully, right?
Just error handling.
Oh, just error handling.
Yeah.
Oh, so who's not familiar with promises? Okay, a couple of you guys. So I don't unfortunately have too much time to talk about promises, but promises are essentially, think of them as a chainable encapsulation of values or an error. So in this case, what we're doing is this function call is a special version of readFile that's going to return a promise. And then essentially the main API on a promise is .then, which will then let us say, essentially, the then here is, I think actually, let me hop back real quick. I think I have a slide. Yeah. So this is probably the best summary of promises, which is essentially, is very similar to callbacks. Here you get both at the same time, and you can deal with your error manually. Here you can optionally pass a second function call to your .then, and you can deal with the error here. If you don't pass that function call, if you don't pass the second function for an error, it will essentially bubble up or get passed down the chain. So I could do .then, .then, .then. This is chainable. So I could add another .then down here at the bottom and handle the result of this one down here. But go look at the promise A+ spec, or look at many of the promise libraries like Q or Bluebird or When. Most of them, I think, actually are promises A+ compatible, which is the name of the specific spec that most of them implement. Yeah, so again, the errors are handled automatically. Okay, so now we're talking about of asynchrony. Where is the relationship with asynchrony and control flow? Essentially, control flow is a library that's built to juggle values, enforce ordering, and coalesce errors of asynchrony. So if I have a bunch of asynchrony, whether they're promises or callbacks or async generators or thunks, I could use a control flow library to juggle those values, meaning grab the first value, the second value, or maybe coerce them in some way, or enforce ordering. So in this case, so this library right here is a library that I wrote called Step Up. The reason why I always recommend people use Step Up is because it's the only known callback-based control flow library that enforces the callback contracts. So if you use Step Up, I guarantee you that every single time this callback is called, the contract is enforced. And to my knowledge, no other control flow library for callbacks does this, although some will do it to varying degrees. Some will sometimes coerce errors into real errors. Some will sometimes ensure that the callback's called with next tick. But because the callback contract hasn't really ever been formalized, to my knowledge, this is the only library that actually does that. So I always recommend it. But my example here is basically to show you here I'm juggling values. So in this one I want to grab just the first value, and this one I don't want to grab any values at all because set timeout doesn't return any values anyways. But I'm also maintaining ordering by saying do these in parallel first and then proceed and go down here and do this as well. And then additionally, I'm coalescing errors. And when I say coalescing errors, what I essentially mean is letting the errors bubble or passing the errors like down the chain. So if, let's say for some reason, let's say this was not set timeout, but it was my own function. If that function called an error, it would both get caught here, or if it had an error after the tick, it would asynchronously catch that error and pass it not here, but down the line to the callback. So it would actually not call your next step if there was an error. So, so essentially, and you'll find that that my library, you'll find that all the control flow libraries essentially are all doing this, right? They're all juggling values, helping you juggle values. They're all helping you enforce ordering in specific ways. That's why they're called control flow. It's mostly about ordering. It's mostly about controlling the flow of your asynchronous function calls and the results that they come out with. And then additionally, they will help with errors sometimes, depending on the library. But the point here being that this is not unique to callback-based control flow. It's actually also applicable for promise-based control flow. So it's important to think of these as two separate tiers. There's an asynchrony tier, and then on top of the asynchrony tier, you can have a layer of control flow. I'll talk towards the end, which is actually pretty much right now, about Co. Co is a library which actually lets you use 4 different types of asynchrony. It lets you use thunks, async generators, async generator objects, which are kind of the same thing, promises, and callbacks. So you actually have 4, 5, 6 separate asynchrony types that you can actually use with one single control flow library. So it's important to think of those as being separate. So again, this is the same example of promises, but using Q. So this is Q, which is a control flow library for promises. It's doing all the same things. It's a little bit lighter just because promises encapsulate their own contract, so they basically can whereas a lot of the stuff in callbacks is a little manual, in promises it's a little more automatic, so it's just a little bit lighter, but not too much. But essentially, whatever value the value will get passed to the string function, which will then stringify the buffer, and then that will become the result of the promise that gets returned. So. So I'm getting closer to the end. I'm going to try and run through these last few real quick. But essentially, I always recommend people think of control flow libraries as the guardians of the contracts, as the gatekeepers between your first-party code and your third-party code. Most control flow libraries don't actually take on this responsibility. But as I was saying earlier, my step-up library does take on the responsibility. I would like to see pretty much all or most libraries take on this responsibility. Because essentially, if you think about the one boundary that you have in your code between your code and third-party code, or your code and core code, it's almost always going to be your control flow library that you make that call into. Very infrequently do you actually make it directly. And so if you're already putting a control flow library between your first-party code and your third-party code, it makes sense then that it would basically enforce that contract and save you a lot of headaches. So this last point here, ensure it doesn't throw an uncaught exception. So I have a library also that I've talked here before on called try-catch. That's an asynchronous try-catch in Node.js. This should probably go 2 slides later, so I'm going to talk about exceptions versus errors in these next 2 slides. So errors versus exceptions. An exception is an unrecoverable error. This is a weird way of stating something that actually has 2 aspects, 2 sides of the same coin. There are errors that are unrecoverable, but you haven't yet forced it, whereas I might say like, oh hey, let's say this value is A and this other value is B, but that should never ever ever happen. And so if I'm in this state where I'm basically saying I'm in an unrecoverable state where I don't know how I got here and I don't really have any recommendation for how to clean it up, that's where you would throw your own error explicitly. Separately, there might be an error that happens that you're not handling. So like, let's say your code checks for a property on null. The actual language is going to throw an error in this case. So this is more of an implicit exception where you don't really have control over the language throwing this error. You can check for it and make sure that it doesn't happen, but it's still going to happen if you don't check for it. And so what makes an exception is either because the state is unrecoverable and you explicitly know that, or because implicitly it will throw and it will tear the stack. And so what I mean by tearing the stack is a stack frame or a call stack is essentially a stack, you have to remember. And so we push stuff onto the stack and then we pop stuff off. So when I traverse down a function call, that's not it. It's not just a one-way street. I have to traverse right back up that stack. And if I don't traverse back up that stack and allow each stack frame to unwind and basically do whatever it was going to do anyways after the function call, there might be something like a database connection closed that doesn't get called. There might be a socket that doesn't get closed. And we found an error in, so one of the use cases that we had for try-catch at LinkedIn was that we found an error in our unit tests, our integration tests, where we were creating errors on purpose, but the event emitter won't call all the event handlers if the first one errors. Essentially, once it errors, it'll say, oh, there's an exception, and it'll stop doing anything. And it turned out that one of the later event handlers was one that Core added that actually closed the socket. So what was happening was when we had these integration tests, everything was working the way we were expecting it to, except for the fact that because of where the error happened, it was causing Core not to close the socket. And so that caused issues, which my try-catch library solved. But the reason why it caused issues was because Core had an expectation that all of its stack frames would be allowed to unwind, and that it would actually get to run this code that would free the socket up. So again, though, it's important to know that sometimes exceptions are desirable. If you're throwing an error explicitly, that's usually because you want to crash, because you're saying, no, this is unrecoverable. I really don't know what to do here. So just to give you an idea what I was saying about stack traces, this is kind of a bad picture, but the idea here is, of course, that when we get here, right, all of these will actually get called, or not called, but get executed, the latter half of their function calls after I reach this point. So once this function is done, we'll continue here, and done, we'll continue here. You just have to remember that. This is a half-finished slide, but I was going to talk, actually let me just hop straight next to the next one. So errors in Node, our exceptions in Node.js are kind of implicitly communicated through uncaught exception. We're basically saying is this error was thrown, so it became an exception when it was thrown. It was not caught, which also allowed it to stay an exception. And because it was not caught, you essentially need to deal with it, but you really should crash. And when I say you really should crash, I just want to bring you over to, let me hop over to the slides, or the docs. Oh, it's all right. It's been a while, actually, since I searched for this, so let's just hop back up to the top. There we go. Warning, don't ignore errors. So this is actually intended, this is written for domains, which are a special way to attach context to an exception in Node. But it actually happens to apply directly also to uncaught exception. And what it's basically saying here is that when you have an exception, it tears the stack trace. And because it tears the stack trace, or tears the stack, you can't recover from it, or you probably can't recover from it, because you're in an undefined state. Because you had a bunch of code that was supposed to execute, but it didn't execute. You don't know if anything in that code is important. You don't know if any of that code needed to run in order for you to continue operating in a safe state, like freeing up a socket, or clearing up some massive amount of memory. And so because you're in an undefined state, whenever you have an uncaught exception, you really need to restart your process. And so because you always need to restart your process on an uncaught exception, I typically define that as a denial of service liability. In other words, if there's some path on your server that somebody knows they can hit and it causes a 500, they know they can keep hitting that because they know you have Node.js, which means that every single time they hit that path, they're going to have to force you to restart your service. They just took down your QPS by, I don't know, like probably 10 times 10, right? You probably can only handle about 10 to 5 to 10% of what you could handle otherwise, because your node processes are going to constantly having to restart. I mean, honestly, you could easily probably take down the entire server that way. So that's a pretty big deal, that one single exception on one single route on one single request can actually cause a total denial of service liability. So that's why I wrote a library called try-catch. Try-catch essentially wraps the user land core boundary in a try-catch. So it's not like a salvation. It's a very pragmatic solution to a problem that doesn't exist in Node, or a solution that doesn't exist in Node. Essentially what this is an asynchronous try-catch. But one of the things that it does that's incredibly useful is that it wraps the userland core boundary with a try-catch so that exceptions don't ever tear the core stack. And so if we can avoid allowing exceptions in userland from tearing the core stack, then we probably can avoid at least the denial of service liability. That is a 500. So it's also nice though, because it'll give you support so obviously it allows you to do asynchronous error handling. So it'll allow you to do asynchronous try-catch, but it also has other nice things like long stack traces. This line right, I'll just go bigger. So this line right here is a tick boundary. So essentially these are happening on different ticks of the event loop. And the coloring also is the default coloring, but red is essentially first-party code, white is core code, and teal is third-party node module code. So, but yeah, so let's try to give you guys an overview of what we talk about, or what we mean when we talk about control flow and asynchrony in the specs. So.